Hello, ladies and gentlemen. Welcome back after fall break. I hope everybody had a relaxing fall break. So today what we're going to do is we're going to do the product rule, which is skill 16. So where this comes from, actually, let's say that I give you a situation like here's a function called f of x, and it is 3x to the 4th plus 2x to the 3rd plus 5x squared plus 1x times 4x to the 5th plus 3x cubed plus 2x plus 1. Do you really want to be multiplying four-term polynomial by four-term polynomial? Nope, thought so. So instead, what you want to do is you just want to break this into two parts. So what you're going to do on this one is you're going to divide it into an f and a g part. So I would actually call this part your f part. In some calculus textbooks, they call it like u and v instead. So the main idea is that you're just dividing it into two parts. So you're taking the f and the g, and then you also want to make sure that you are also taking the derivatives of each of those pieces. And in the product rule formula is going to be f prime g plus fg prime. So you can kind of imagine, I take each part, I take the derivative of each part, and then I use this handy dandy formula, which is the product rule. And this is what you should remember all the time. Okay, let's actually look at a sample situation here. Now, example one, you could, do the polynomial multiplication or the FOIL and then get it into a power rule. If you really like the power rule and sing high praises to that, you could do that here. But what we could do instead is just do the power rule. So what I like to see happen every time is that you just write your f and then your g and then you write your f prime. So let's see, that's 3 minus 4x, and then your g prime is 4. And I'm going to write my formula, so I write, and order, doesn't, so as long as your f prime is with your g and your f and g prime are together, you're good. I even like to draw little arrows like that. So I would write f prime g plus f g prime. So I write 3 minus 4x times 5 plus 4x plus 4 times 3x minus 2x squared. And that gives me a power rule derivative. And I would even, and just kind of like link this to your h prime of x. And, if you left it like this, this shows me that you know the product rule, so you're good. And they will even accept that type of answer on your Delta math as well. Okay, let's go now and take a look at another example or two just to make sure we're kind of in the rhythm. This is a skill that goes really well for people when they get into the rhythm of it, so to speak. Here's a few more examples to try. You can kind of see that the level doesn't change too much, but what you will see occasionally is that negative exponent type of scenario. So I always like getting in the habit, call them like f and g, even if they're called like f of x. So I write f equals to 5x to the fifth plus 5, and g is going to be negative 2x to the fifth minus 3. F prime equals to 25x to the fourth, and it's just 25x to the fourth. Remember, the derivative of a constant is 0. And then g prime is going to be negative 10x to the fourth. And I write my formula, so maybe I write f prime g plus f g prime. I even write that on the top, and then I just set it right up. So I have f prime, which is 25x to the fourth, minus 2x to the fifth minus 3. That's your f prime g. And then I add to that your f, which is 5x to the fifth plus 5. And your g prime is negative 10x to the fourth. Then you're done. So you may be saying, does it get any harder? Well, I do have a right to kind of up the ante a little bit with like negative exponents or fractions sometimes. So if we look at an example like this, I have that my f is negative 3 plus x to the negative third. I may not be as kind sometimes. I could actually give you, like on delta math, like 1 over x to the third. This is really just like the same problem. And then your g is negative 4x to the third plus 3. So my f prime would be, well, let's see, negative 3 goes away. So then you'd have negative 3x to the negative fourth. And then your g prime would be negative 12x squared. So then I just used a formula that I wrote on the top corner. So my derivative would be cross out that parenthesis right there. So my derivative would be f prime g. So I have negative 3x to the negative fourth times negative 4x cubed plus 3 plus negative 3 plus x to the negative 3 times negative 12x squared. If it asks for no negative exponents, so sometimes it may ask, you could just rewrite it as negative 3 over x to the fourth times negative 4x cubed plus 3. And then I do negative 3 plus 1 over x to the third. So you could kind of imagine a 1 as that coefficient times negative 12x squared. So what's good about this is you can stop there, and this tells me that you know the product rule. And number 7 is kind of good for you to try. I'm going to leave that for you to try before the delta math. Only difference there is that we throw in something with 3 terms. So that is really what the product rule is. So it's just a nice way to kind of chunk those derivatives into 2 parts. So it's a product of 2 polynomial expressions. You label them by their 2 parts. You take the derivative of each part, and then you incorporate it into the formula. And if you are good with that, there isn't really too much else.